Hello, graph theory, and today we will discuss handshaking lemma and paths. First of all, a handshaking lemma. This is intermediate theorem, and we will use this theorem many times in different occasions. It says that the sum of the degree of the vertices of a graph, and that should be, which is a tree, that should be double of the number of edges. So the degree of uh, vertices, sum of the degrees of the vertices is a double of the number of edges. So this is the recently we have constructed this graph. So this is a graph. So degrees of vertices A, B, C, D, E, F, G, H. So these are the vertices. So that A has uh, 1 degree, 2, B has 2 degrees, C has 1 degree, D has 3 degree, and then E has 1 degree, F has a 4 degree, G has only 1 degree, and H has only 1 degree. So let's add them together. This is the number comes with the 14. And number of edges is in between vertices 1, 2, 3, 4, 5, 6, 7. 7 edges, so is it exactly double of this double of the edges is equal to the number of degrees of this graph. So this is a tree graph. So this we can say that left hand side of this one, the sum of the degree of the vertices is equal to the double of the edges. So this, if this is this holds, this graph is a tree. This is a useful lemma. Now we will discuss paths. There are two kind of path. One is called Eulerian path, in which we cross only the edge once, and there is a Hamilton where we cross only the vertices. So if Eulerian path, that we have crossed the edges once. So this one will be that we cross the edges. So edges once. So like this one. So this one. So we have crossed only the edges once. So it says that if the start and the finish vertex has a degree 1 or odd, so then the Euler path have this one. So Euler path only if the vertex of each vertex is even. So this is to prove. So to disprove this one, we have to assume this one only if the degree is even. If degree is even, the graph of the even degree is a cycle, and the cycle is not allowed in a tree. So if it is not allowed, our assumption is wrong. So assumption is even degree, and this comes as a cycle. So start from the even degree, and we end up in a cycle, and cycle is not included in tree. So that means our assumption should be otherwise. So otherwise means that is instead of even, it should be odd. If we have odd uh, tree, a tree with the odd initial and start, then that path will be Euler. If it is this one, like this one, this is a cycle, but it has a degree 2, but it is at a one path because of the cycle. Hamiltonian path. So if we consider a graph which have n vertices, and there are some uh, adjacent and non-adjacent vertices. So this is 1, 2, 3, 4, and 5. So adjacents are the adjacent, this is close to each other. So this one has adjacent 2, 5, and 4. Likewise, 1, 4 adjacent, 4, 5 adjacent, 4, 3 adjacent, uh, 5, 3 adjacent, 5, 2 adjacent. Non-adjacent are which are there is no link in between. So the 1 and the 3. So this is non-adjacent. So this is non-adjacent. These two and 2, 4. So it says that the vertices are 5 vertices, 1, 2, 3, 4, 5. So it says that if the degree of the vertices, this one, this is the condition, degree of the vertices of any vertex u and degree of the vertices of any vertex v should be greater or equal to n. So we take vertex 1 and 3. So vertex 1 has a degree 3, 1, 2, 3. And vertex 3, this is our, we have selected this one, 1 and 3, 1, 2, 3. So 3, 3, 6. So vertex 1 and 3, 3, 3, 6. So we have got number 6. And that should be equal, and the total number of vertices are 5. So 6 is greater than 5. So then there exists a Hamiltonian path. So there is a Hamiltonian path is this, that uh, we can use only vertex once. In Euler, edges. In Hamiltonian path, vertex. So we can use the vertex only once. If this is the condition, the uh, degree of the vertex 1 and degree of vertex final should be less than equal to the total number of the vertices. So from going to this one, so you can have this path. This is called Hamiltonian path.